I'm here today to do 5 sessions around Windows Azure, the Windows Azure platform, to try to tell you a story from the beginning to the end. And I'm sure that some of you guys already have started working maybe with the Windows Azure platform. Give me a quick raise of a hand if you've already started doing that. Okay, so some have and some haven't. My job really today is to take you through 5 sessions. You don't have to come for every session. It's not compulsory. You may have other things that you want to do. But we're going to start off with a look at writing applications, writing services with Windows Azure. Windows Azure is not the Windows Azure platform. That's why my slide says Windows Azure, not the Windows Azure platform. The platform is a much bigger entity than just Windows Azure. And as we see as we go through the rest of today, we'll talk about things like SQL Azure, so SQL Server for the cloud. We'll talk about Windows Azure App Fabric, for connecting applications and services together. We'll talk about the possibility of you developing hybrid applications, making use of some on-premises work and some off-premises work, and look at how the Windows Azure platform can help you with that. But really our starting point this morning is to talk about applications and services with Windows Azure, just that one part of the platform. For those of you who want to, I have with me some magic pieces of paper, which I'm told allow you to have a 30-day free trial, courtesy of Microsoft, of the Windows Azure platform. If you would like to take one of these, then please feel free to see me at the end of this session or any other session, but please only take one. I only have 200 of these, and looking around me in the room now, we already have something like 105, 110 people here. So if you all take multiple ones, it will run out very quickly. Okay. What we will do at the end of the session, guys, is we'll have a chance for questions. It's very difficult with so many of you here right now to do questions as we're going along, but certainly at the end of the session we'll have 5 or 10 minutes, depending how quickly I speak, for you to ask questions about anything that I may not have covered or anything that you perhaps want to know slightly more about. And at that point I'm afraid you have to talk into a microphone, not this one, nor that one, but a special one that will be circulated amongst you guys. So what I'd like you to be able to do today, by the end of our hour together, so at 11:30, I'd really like you to be completely aware, if you're not already aware, of Windows Azure Compute, the compute application development part of Windows Azure. We'll talk more about Windows Azure Storage in the second session, but I'd like you to go away knowing all about Windows Azure Compute, what you can do, how you can do it, the rules that you have to follow that David's already alluded to in the keynote. Understand some of the terminology and some of the way in which we write applications for Windows Azure, the models that we have to use, and in particular have an awareness of the 3 different roles that exist in the Windows Compute space. In other words, web roles, web front ends, worker roles, which we can think of as middle tier or servicing components, and this wonderful thing called the virtual machine role, that is something that we can talk about and I can show you how it works, and then perhaps I'll probably tell you that you should think about that as the very last option if you want to be using Windows Azure Compute. So an understanding of those 3 different roles, understanding how we can write applications that use those roles, and seeing some of the issues that will confront you as a team of developers or a group of developers. So what is Windows Azure then? Well, Windows Azure, as I said right at the start, bless you, is just a very small part of the Windows Azure platform. It's made up of 2 component parts. It's made up of a compute environment, in other words, where we write applications. It's made up of a storage section, where we're talking about storage of data that our applications may or may not use, running in the cloud, or perhaps running as on-premises applications. And Windows Azure has often been described as this thing, the operating system for the cloud. It's a mechanism for running your applications, for managing your data. And you guys will know, because I know that you all paid special attention to David's keynote, about the idea of platform as a service, where the only thing you care about is the writing of your application and the management of that data within that application. Very different from infrastructure as a service. Some of you guys will have come across infrastructure as a service through your understanding of cloud computing. Very different from software as a service. Although using platform we can start to help our customers build out applications that run as software as a service. And that's one of the things that I think people miss a lot of, is that they see the Windows Azure platform and Windows Azure as being platform as a service and don't necessarily see that that's a mechanism for them to be able to write their own software and provide that software as a service to their customers. So we'll talk about more around Windows Azure as we go through, but really we're talking here about the ability to write highly scalable, highly available, fault-tolerant applications with almost infinite elasticity. And so we'll talk about all of those things as we go through this morning. In a slide, we can think of Windows Azure like this. We can think of Microsoft running a data center, whether that data center be in Amsterdam or Hong Kong or Houston. Around the world, the Microsoft data centers supporting the work that you guys want to do with Windows Azure. Those data centers, as you already know from being at David's keynote this morning, are responsible really for provisioning virtual machines for your applications to run upon. And those virtual machines will run either in the storage cluster, where they're providing storage for data, and we'll talk more about that in section 2, or we're talking about a compute cluster where your virtual machines are running your applications, your web roles, your worker roles, your virtual machine roles, within virtual machines inside that data center. And any of you guys who've looked on the web for how those data centers are constructed, you'll know that Microsoft have a series of containers that run highly efficient blades that provide mechanisms for running these virtual machines. You, of course, are developers, or you're perhaps working within a development team. You will want to be doing your work, writing your applications, in an environment that you are happy with, you are familiar with, using the tools that you're happy and familiar with. So you'll still be writing these applications using Visual Studio, using an application of your choice, and you'll be doing that locally, working in your normal desktop environment, as you would do if you were writing an on-premise application. Some slight differences: if we're using Visual Studio, for example, we do have to make use of the Visual Studio tools for Windows Azure, and we do have to make sure that we've downloaded and we've installed the Windows Azure SDK. Those two utilities, if you like, provide us a mechanism for writing Windows Azure applications. At some point, we will deploy our applications, and those applications will run in the compute cluster on virtual machines, by little black blobs here. And within each of those virtual machines, we can think of that virtual machine belonging to you, running your web role, running your worker role, running your virtual machine role. Your user code is part of that virtual machine, but there is also supporting functionality within that VM to keep your application running. The runtime API, the setup of the virtual machine. All of these things are provisioned and managed for you by Microsoft, and they're not necessarily something that you worry about or that you really have much interaction with. Your job, your development team's job, is to write the application, deploy the application, and let your users use it. How do we do this? Well, at some point, you guys will have to go away and sign up for subscriptions. Those of you who raised your hands earlier to say that you're already messing around with, working with the Windows Azure platform, you will have already done this. If you haven't done this, you will have to go and set up your subscription. You can set up your subscription here. So go to windowsazure.com, sign up, decide which types of subscription you want, pay as you go, pay monthly. You'll need a credit card. Don't worry, it's not all bad. You'll perhaps sign up for the free trial, or you'll make use of my wonderful free pieces of paper up here, to set yourself up with a subscription into Windows Azure. Once you've done that, you will then have access to the management portal, which looks like this, where you can start to work with the platform as a whole, where you can start to work with things called hosted services, compute applications, where you can start to work with storage for Windows Azure, where you can start to work with SQL Azure through the database options and reporting and data sync, and you can start to work with App Fabric through things like the service bus, the access control service, caching, and so on. And if you're writing Windows Azure Compute apps, one of the things that you will do is create these objects here called hosted services. These hosted services give you a globally unique URI from which your compute applications are available. And you'll notice if I go into one of mine, if I go into QA Starter, for example, you'll see that as I come down here, I have my globally unique DNS name, http qastarter.cloudapp.net. Nobody else in the world can have that. It's all mine. I can't have one of yours. And when I configure my hosted service, I decide upon a DNS name and I decide upon a geographic location that my hosted service will be running in. Will it be running in Amsterdam? Will it be running in Dublin? Will it be running in Singapore? Etc., etc. I get a simple choice. So subscriptions are an important part of getting started with Windows Azure, but they're really just logistics. They're just management. What really we want to know about is how do I start to write applications for this platform? Okay, so subscriptions themselves, made up of a number of services, as we've already seen, and the service, as we've already seen, provides a public URL, is an isolation boundary, a siloing of your application, and can be made up of up to 5 roles, web roles, worker roles, within each of these services that go with the subscriptions. So when I create my application, I can say that I want my application to run a number of web roles or a number of worker roles. And I think one of the things that David mentioned this morning was that if you want to make use of the Windows Azure SLA, you need to be running 2 instances, 2 roles of your web or worker roles to make use of that SLA. Okay, but a maximum of 5 of those roles within each of your hosted services. Of course, roles and instances aren't quite the same. Roles in their own right, the web roles, the front ends, the worker roles, the middle tier components, if we like, are slightly different from instances. Instances, the number of virtual machines that will run your roles. And again, that goes back to David's comment this morning, where we need to run at least 2 instances of each of our roles to make use of the Windows Azure SLA. Each of those roles will specify, amongst other things, the size of the virtual machine that you want to use. You might go for a very, 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 very tiny virtual machine that has a limited amount of RAM, has a limited number of cores, or you may go for an extra large virtual machine that has considerably more RAM, has considerably more processing power through making use of a higher number of cores. And we'll talk about that as we go through this morning. What's important to remember, though, is that at runtime, each of the roles, the web roles, the worker roles that you create, will run on 1 or more instances. So I will have 1 or more virtual machines. And I can have up to 20 of those instances per subscription. Okay, now this could get quite confusing, couldn't it? I've been talking about roles, I've been talking about instances, I can have 5 roles per service, I can have 20 instances per subscription. This just sounds a complete nightmare and sounds very difficult to deal with. But essentially it means that within my hosted service, I can have a maximum of 5 roles, and within all of my subscription, all of my hosted services, I can have up to a maximum of 20 roles in the default configuration for Windows Azure. But if you want more than that, it's a telephone call and a bit more conversation with Microsoft to help you out on that. Okay. How do these Windows Azure applications work then? Well, let's imagine a very simple Windows Azure app. It perhaps makes use of a web role. It perhaps makes use of a worker role. And you'll see here that I've tried to represent the fact that I may have a number of instances, a number of virtual machines running identical copies of my web role and my worker role. I can deploy my web role. I can say that I want to have 3 instances of it. 3 virtual machines will spin, and I will have the ability to connect to my web roles through the load balancers managed by Windows Azure on the Fabric via TCP or via HTTP, allowing my users access into my web roles. Of course, David mentioned this morning, we have to be stateless. You know, we're working in a stateless environment. Calls made to my web role, I have no idea which web role the load balancer will choose for each request that I make. So as my user comes in to use my application, they may connect to instance 1. And as they move to the next page, they may connect to instance 2. But they may connect to instance 1. And actually, I don't really know. I don't really care which one they connect to. All I have to do is to write my application so that it doesn't matter which one they connect to. Do they connect to instance 1, instance 2, instance 3? Make sure I write my app in such a way that it does not matter how they connect into my front end. I have a similar situation with worker roles. The worker roles whose job it is to do kind of back-end processing. I guess most of you guys could probably write me an ASP.NET website, or you could write me an MVC website, or your teams could do that. And you could probably write such a website so that you had all of your processing code in the code behind of your button clicks and all the rest of it. I could do that. I'm sure you guys could do that. And that would be a really bad way to work, wouldn't it? Would that be a bad way to work? You know, have all of my processing code actually in the button clicks and the drop downs and all the rest of it? That would be bad? Yes, okay. A little bit of a nod. Yeah. What I really want to do is I want to hand off the processing to some kind of middle tier component. Yeah. I would probably want to do that on premises. I certainly want to do that when I'm working in the cloud. And that really is where my worker roles come in, my worker roles whose job it is to do the processing for the front end of my application. I can talk directly to my worker roles. I can talk over HTTP. I can talk over TCP. Again, there'll be load balanced functionality that allows me to do that. I can do that even if I haven't got a web role, even if I do not have a front end, if you like, for my application. And I can also talk from my web role to my worker role directly, or I can talk to my worker role from my web role, perhaps making use of some of the ideas around Windows Azure storage, which we'll talk about in the second session, passing information into these things called queues, allowing the workers to pick up information from the front end and process that information in a very scalable and reliable way. And so my mechanism of communication within Windows Azure is slightly different, perhaps, to what you're used to in an on-premises application. How do I do all of that in something like Visual Studio? Okay, here I have a little virtual machine, and my virtual machine has within it Visual Studio, of course. If I want to, I could go and create myself a brand new project, and that project, having installed the Windows Azure tools, could be a Windows Azure project. And as I go away and create my project, one of the things that the project wizard will ask me is, what kind of roles do you want to have within this application? And this is going to be really important as we go through the rest of the day. We could have a straightforward ASP.NET web role, functioning in almost exactly the same way as you're used to with an ASP.NET website. We could have MVC2, MVC3, MVC4 web roles. We could have a WCF service web role. In other words, a service that's exposed without necessarily having a front end, allowing me a scalable and very elastic way to provide services that I might normally do on premise. So I don't have to have a front end, but the WCF service web role is still a web role. It still functions as a web role. It's still configured as a web role. It's just providing typical WCF services. I could have Silverlight. I could have worker roles that are there to do the background processing. And as I go into the creation, I can say, I'll have a web role, and I'll also have a worker role. I can give them new names because I don't like web role 1 and I don't like worker role 1. So I could come into here and I could rename it, call it whatever I like. But I can think of my web role as being, in this case, the front end, because it's ASP.NET, and I can think of the worker role as something that does some background processing. There is nothing to stop me from having multiple web roles. So, for example, I could provide a web role that was accessible through the Azure virtual machine that ran on port 80 on IIS in that virtual machine. That's my public-facing web role. I could define another web role that perhaps ran on port 8080 within IIS on that Azure virtual machine. That might be, for example, my application administration front end. So I can have as many web roles as I like, as many worker roles as I like, as long as you follow those rules of no more than 5 per service and no more than 20 per subscription. Similarly, I could have multiple worker roles. Those worker roles, for example, might do different types of background processing. I, for example, might have a worker role that was responsible for image processing. And maybe I allow my users to upload large pictures, and I want to be able to thumbnail those pictures into something that's a bit more manageable on my website. My worker role could do that for me. I could have another worker role that perhaps was involved in writing to a database table, or writing into Windows Azure storage. Different functionality for each of the different worker roles. But I could have a worker role that did all of those things. It had a method that was responsible for thumbnailing images. It could have another set of functionality that was responsible for adding data to a database table, or updating data in a database table, or pumping data into Windows Azure storage, for example. So my different roles provide me with the mechanism for a front end, in this case the web role, and provide me with a mechanism for background processing of work that needs to be handled from the front end. Now, I've already created one of these, so what I'm going to do is just step away from there a second and come into probably what is the simplest situation we could have. Of course, it's, hello Windows Azure. And you'll notice over here that once I've created my application, what I have is my web role and my worker role. And those web and worker roles are represented by my web front end and also my worker background processing component. And those of you guys who write ASP.NET web applications, well, that web role looks a bit like an ASP.NET web app, doesn't it? It has all of the usual folders. It has the default.aspx, about.aspx, exactly the same structure as you might be wanting to work with because you're used to it in an on-premises world. It's done deliberately that way so that you don't have an enormous learning curve about the basic structure of your application. And then I have my worker role that's really going to be my little DLL that's doing some work in the background for me. You might have to edit that bit out. If I look in my worker role, here's worker role. Some code, heaven forbid us. Some important methods for worker roles. You'll notice that the worker role inherits from this class called the role entry point. In fact, all web and worker roles inherit from the role entry point. It's a Windows Azure based class. And you'll see that I have an onStart method. I can't for the life of me think when that might fire. Perhaps when the virtual machine spins up. Quite an important method, because in here we can start to write what are called startup tasks, that we can use to configure extra functionality within the virtual machine, for example. We have another very important method called run, whose job it is to run the worker role. And as you'll see here, it says replace this sample worker implementation with your logic. Please, whatever you do, don't return out of this loop. That would be really silly, because your worker role is going to die if you ever come out of this loop. So a very common pattern that we have for worker roles is what we might call a polling worker, where every second, half a second, 10 seconds, whatever duration we choose, we can ask the worker role to go and poll and look for information that perhaps has been posted to it from the web front end. The default implementation here is just to write out into my log the fact that I'm working. It's not really going to do much for you, but every 10 seconds it'll wake up and go, hello, I'm working. In my web role, yes, I have a front end. It's a front end like a normal ASP.NET front end. I also have the web role, and you'll see here that the web role also inherits from role entry point and also has an onStart method that we can start to use if we want to customize the behavior as the role starts. Now, one of the things you don't want to do is you don't want to spend your life working on writing your application locally in your desktop, and then every time you test it, you have to deploy it up into Windows Azure. That's the last thing you want to do. What you want to do is work locally, debug locally, test locally, that dreadful word test, do all of the things that you would do with an on-premises application, but to do them locally before you deploy your application into the Azure platform. Fortunately for you guys, installing the tools that we require for Visual Studio builds us emulators that allow us to run the application locally and emulate the way it would behave in the cloud, so that we don't have to deploy it up into the cloud to test how it works. We have two emulators. We have an emulator for compute that makes us behave as though we are running in the cloud, and we have an emulator for storage that allows us to pretend that we are using Windows Azure storage through something like SQL Express or a full version of SQL. Both of those emulators are available to us. I've run this application this morning. Here's my compute emulator, and it will show me in my worker role instance, for example, there it is, every 10 seconds is writing out working, because that's what the run method said to do. Clearly here, with my trace statements, I can output into the emulator to really understand what's going on inside my worker role. Still working. In my web role, this is my instance of my web role. Of course, it's just sitting there, polling along, not doing anything at all, just running the web role, just reporting out that everything's okay. But my compute emulator, a very important place for us to be when we're actually testing and running our applications locally. Okay. So, web roles, worker roles, the real core to writing Windows Azure applications. We've talked about onStart, run, and onStop. Well, at least we've talked about onStart and run. onStop is also going to be very important. I can guarantee you that your web roles and your worker roles will recycle. I can guarantee you that. I can guarantee it you because Microsoft can guarantee it you. They will recycle the virtual machines that run your applications periodically. You don't know when that's going to happen. You don't know whether it's going to be in half an hour or whether it's going to be in 30 days. But your virtual machines will recycle, and you may have to be careful about using the onStop method to clean up gracefully any of the work that you've been doing, because you have 30 seconds to tidy up all of the work that your role might have been doing. So, for example, your worker role that's in the process of thumbnailing an image, onStop may get called halfway through processing it. You need a way of managing what to do with that thumbnail image. Can you get the work done before the 30 seconds is up? Or should you be a little bit more creative and perhaps hand the image off to another worker role? It's not quite the same as on-premise. So, web roles, talked very briefly about them so far. ASP.NET 3.5, 4, MVC, web forms, PHP, communicated with over HTTP or HTTPS. A variety of different levels of functionality that you can make use of depending on the type of application that you want to run. Worker roles tend to work in a variety of different ways. A very common way is for those worker roles to be queue polling worker roles. In other words, they are trying to read information from Windows Azure queues. That information has been pumped in from the web front ends, perhaps, Here's an order that I want you to process. Here's an image that I want you to thumbnail. Here's something I want you to do with some logic that writes to a table. Information going into the queue to tell the worker role what to do, the worker role picking the information up from the queue and processing it according to the method that's appropriate. We can have listening worker roles that usually make use of things like TCP listeners, for us to communicate with the worker role over TCP, passing information to that worker role, listening for that information coming in across TCP, and then taking some action. Sometimes we have these things called external process worker roles. Often they'll use startup tasks to really customize how the virtual machine in which they're running is going to behave. So, for example, you might want to run additional functionality on that virtual machine, and you'll use the start or run methods to start up separate processes. But most often, up here, worker roles that poll against queues, pull information from the queues, and start to do some work against those messages from the queues. When you write your application, one of the things that you will find is that the definition for the application, the service definition, and the configuration for that service are written in two very special files. They're written in files that have these extensions csdef and cfg. The service definition and the service configuration really define what it is you're going to deploy and how you're going to deploy it. For example, if I was to switch to my virtual machine over here, if I was to look in my web role and I was to look in the properties of this web role, if I go into my configuration section, you'll see that I'm going to ask when I publish this web role to Windows Azure, I want to have one instance of this web role, and I want to have that one instance of this web role, in other words, one virtual machine. I want to have that instance a small virtual machine, itty-bitty tiny virtual machine. But I could choose to have a variety of different sizes, extra large to extra small. And we'll talk about what those mean in a minute. So I can here say I want to be able to have a number of virtual machines running, 1, 2, 4, 100, well not 100, and I want to have different sizes of virtual machine that have different levels of functionality made available to my web role. And we will see those limits in a second. You'll see that I can also, in my endpoints section, I can start to create and work with endpoints that allow me to communicate with my web and worker roles. So for example here, my web role has an input endpoint. It accepts input from outside the virtual machine against port 80. What that really means is I am going to deploy this web role to the Windows Azure VM. IIS will run that web role and it will be accessible over the default port 80. Of course I can change that. I can even add in extra endpoints, and those endpoints can be of two different types in the web role. They can be an input endpoint. I'm communicating into the virtual machine from outside. Or they can be an internal endpoint, allowing communication between roles within my application. They're not endpoints that are accessible from outside. They're accessible only from within my application, so that I can talk to my application across these different endpoints. The same would be true if I was to look at my worker role. If I look in properties here, again you'll see I have one instance. It's a small virtual machine. I have endpoints. In this case, I can have input and internal, and I can have TCP, HTTP, deciding what kind of communication I want to be able to provide to my worker roles, either from outside, the input endpoints, or internally, allowing my worker roles to communicate across between themselves, or allowing my web role to communicate to that endpoint that's only known inside my application. So, configuration, definition, these are things that allow Windows Azure to understand what it is that's being deployed how many instances are being deployed, what size of virtual machine that is required when I spin the application up. And when I deploy my application, all I'm really doing is zipping up my code, packaging it with the definition file, which looks at my configuration file, I should say, which looks at my definition file, and uploading that information into the Windows Azure platform. How do I do that? I do it very easily. I essentially go here, and I say I want to publish. As I choose publish, I can say where I want to publish my application to. This was something that I did yesterday, rather than this morning, and I actually published this application to my QA starter. Here they are. This is my Hello Windows Azure, the application that I have running in my virtual machine, and I said I wanted to publish, so I have one worker role and I have one web role. That's what my configuration file said to do. So I'm not really getting the SLA here, but that's the least of my concerns. Yeah, what I'm getting is I'm getting the ability to have my worker role published into Windows Azure and have my web role published into Windows Azure. And of course, I can access that through qastarter.cloudapp.net, and there is my application exactly the same as when it was running locally. Now, okay, there's nothing really going on there. It's just a front end. It's not talking to the worker roles at all, but we'll talk more about that when we come on to storage later on today. But in terms of writing, publishing the applications, a very straightforward process. Okay. So we've talked about service definition and configuration. One thing I do need to make you aware of is the different levels of virtual machine. I always get asked lots of questions about price. How much does all of this cost? It's one of the things that people really worry about. The answer is, it costs whatever you want it to cost. The more you use, the more it costs. Everything is on a pay-per-use basis inside the Windows Azure platform. Very much so inside Windows Azure Compute. You are charged for Windows Azure Compute on a CPU per hour basis. Different sizes of virtual machine, from extra small all the way through to extra large, have different numbers of CPU cores. A small virtual machine, for example, has one core. It has 1.7 gig of RAM, roughly. It has 250 gigabytes of local filing system resource. And it costs 12 cents per hour to run. That's dollar cents, not euro cents, not pound pennies. Yeah, that is $12 cents per hour. I have no clue how that equates to euros. Those seem to go up and down quite a lot at the moment. As I move forward into medium and large and extra large, what I'm really doing is I'm saying I want more cores, I want more RAM, I want more local filing system resource. And you'll notice that the pro rata pricing is per CPU, core, per hour, 12 cents, 24 cents, 48 cents, 96 cents per hour. If you have an extra small VM, you're having shared CPU, so you're perhaps sharing with other users of the CPU, but of course that's only 4 cents per hour. One thing I would say to you is, please do not, when you write Windows Azure apps, do not rush off and expect to use multiple cores. Multiple cores have nothing to do with providing scalable apps. Multiple cores give you highly processing efficient apps. If you needed to do statistical manipulation, complex mathematics, yes, you might decide to go and run more cores because you need the processor to crunch those numbers as quickly as possible. The more cores, the more you can crunch. Scale in your application is not managed by having additional cores, it's managed by having additional instances of your application, of your web roles and your worker roles. So you may decide I want to run 3 instances, 4 instances, to provide the scale for massive numbers of users. That is not necessarily to do with the number of, or the amount of cores or the amount of RAM. Interestingly, each of the instances of the role, the web role or the worker role, will always be the same size. You cannot say, I want this instance to have 2 cores and this instance to have 1. All instances will be the same. So, don't just throw a big virtual machine at every problem. Scale is about having more instances. Processing power is about having more cores. Okay, talked about networking. Local storage, not to be confused with Windows Azure storage, which we will do in section 2. Local storage is locally available disk storage, disk space, and the code running within your applications has access to that local storage. That local storage provides you with a mechanism for storing content that you need in a transient kind of way. It is persistent, but it's not guaranteed durable. In other words, if my role recycles, I need to do something quite radical with my local storage content. Other possibilities, these things called Windows Azure storage drives, which we'll talk about in the second section, actually provide us with a much more guaranteed, durable mechanism for storing content. But that local storage is available, and I can define it inside my configuration file to say my local storage is called this, my local disk, the size in megabytes is whatever it happens to be, and then I can start to use that in code by using my get local resource, and using it as though it were just a filing system. And I'm sure for those of you who are coders, that's not particularly frightening. There will come times where you want to upgrade your app. How can you upgrade your app? And what do I mean by upgrade? Really what I mean is I can upgrade in 2 ways. Going back into my management portal, you'll notice when I look in my services here, up at the top, I have this option, a new staging deployment or a new production deployment. When you write your apps, you will have developed them, you will have debugged them, you will have tested them locally. You will want to move them to the cloud and you will want to test them. You will do that by using the staging deployment, a testing, staging environment inside Windows Azure. The staging deployment allows you to deploy your application by saying publish from Visual Studio, but it puts your application into a location that isn't really your public URL. It's a very odd looking URL. But you can test your application through that staging deployment, and then you can swap it into production using this, the swap VIP. If I had a staging and production environment here, I could swap staging to production, production to staging. So I can deploy version 1 of my product into staging, test it, life is good, move it to production. I can then deploy version 2 into staging, test it, I'm happy, swap them, so that what was in production is now in staging, and what was in staging, version 2, is now in production. And that VIP swap gives me a very quick and easy way of moving the application, upgrading the application from one version to another. It is also possible to do upgrades. So I can upgrade a particular deployment. And as you can see here, as I hover over that, it will say upgrade the selected deployment with a new service package or configuration. So for example, I might say I need another worker role. I can upgrade that worker role. Or I might say I want to have more instances. I can upgrade that through the configuration file. No need to redeploy, just a simple upgrade in the number of instances that I have running. So a very flexible and easy mechanism to use. Are you guys happy with web and worker roles? Do you think you get the plan? Sort of? Okay. There is one other role, which I think David may have mentioned in his keynote this morning very briefly, this thing called the virtual machine role. And as soon as I talk about virtual machine role, everybody looks at me and they go, ah, so this is the Amazon thing, isn't it? This is where you deploy your virtual machine up into Windows Azure, and it does what Amazon Elastic Compute does. Yeah, it allows me to deploy my virtual machines and do whatever I like within them and run in an infrastructure as a service way. And I have to calm everybody down and say, no, 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 no. Everything in Windows Azure is platform as a service, not infrastructure as a service. It appears from the outside that the virtual machine role perhaps looks like Amazon EC2, but it's very and fundamentally different. Yes, it does allow me to upload virtual machines. Yes, it allows me to use those virtual machines through a URL or through a remote desktop connection. Yes, it allows me to deploy things like Windows applications, and have those applications running on a virtual machine in the Windows Azure platform. But it's very different from infrastructure as a service in that as my virtual machine role recycles, it will start back up again in exactly the same flavor as when I first deployed it. By that I mean, for example, if I were to use the virtual machine role to deploy an image that perhaps had a SQL server on it, and I was to write data to the SQL server, yes, whilst the VM role was up and running, that VM role will recycle. I guarantee you it. It will recycle sometime between now and 40 days from now. And when it spins back up again, it will spin back up in exactly the same state as when you deployed it. In other words, the 150,000 rows of data that you've written to your SQL server will not be there. Okay, so it's very important to recognize that the virtual machine role is not infrastructure as a service. It is platform as a service. How do we do this? Well, we do it in a very similar way to using web and worker roles. So, for example, I have a VM role project over here. You'll notice it has in its roles section a virtual machine role. The virtual machine role is just like a web role or just like a worker role. It's a role that I can add into my application. I can then, with my virtual machine role, I can say, what I want you to do is I want you to look at a particular virtual hard drive that I've already uploaded. Here's one, my VM role base image.vhd. To do this, you will be working with Hyper-V. You will build yourself a Hyper-V image. The image will contain all of the software and the applications and the things that you want to have deployed on that image. And you will upload that image into the Windows Azure portal. It's done just here. So in my VM images, here is my VM role base image.vhd that I uploaded into Western Europe at some point in the distant past. And I can connect my VM role in Visual Studio to that virtual machine role image that I have uploaded. I then, through my virtual machine, simply do the same things as I've done before. So I would say I want to publish my virtual machine role, perhaps configure the ability to do remote desktop connections, publish the role into the portal, and that will then allow me to go back into my hosted service. This is my virtual machine role. Here it is, the HR Skills VM role, instance 1 or instance 0. And you'll notice that what I can do is, as I go through these, I have the ability to connect through a remote desktop session to my virtual machine. So I can connect here, start up my remote desktop. I'll just open that up. Okay, I'll log in. That's one of the things that you do have to set up, by the way, when you're doing your Hyper-V virtual machine. You need some login accounts. And don't think you can get away with the administrator account, because you're going to sysprep your machine before you load it up, and the administrator account, when it first boots, will be disabled. So don't make the schoolboy error the first time I did this, quite a long time ago, which was, yeah, I'll log on as the administrator, that'll be fine, only to find that my virtual machine, when it booted, didn't have an administrator account I could log on with, didn't have any other accounts that I could log on with, and I'd spent 8 hours uploading it into the platform, so I had to go through all of that all over again. Here's my virtual machine. My virtual machine has 2 very simple apps running on it. It has a Windows app. The Windows app connects to SQL Azure. You maybe don't believe me, but it does. Yeah. Not shabby speed-wise. This is a virtual machine role running in a virtual machine in Amsterdam that's connecting to a SQL server that's running in Dublin. That information available through that Windows UI was, I don't think, too shabby at all. That was quite quick. I have a web application that does the same thing. But I know at some point in the future, if I start to write new content into my SQL Azure database, that's going to be okay. But if I write content to a SQL server running in this virtual machine, that is not going to be okay, because at some point in the future, my VM will recycle and I will lose all of those changes. Yeah, so VM role, powerful, but please don't rush off to use it unless it is absolutely the right thing for you to do. Yeah, it has limitations and implications, yeah, that you need to be aware of before you start to use it. Okay. Just get rid of my remote desktop. So, how do you do it? You do this. You build your virtual machine. You build your Hyper-V virtual machine. You prepare it. You sysprep it. You create a new service, as in the VM role running inside Visual Studio. You upload your image. Yeah, the image is actually stored in Windows Azure storage. You deploy your virtual machine role service, and then you can remote desktop into it, reboot it, re-image it if you so wish. And if you want to, you can upgrade your service by providing a brand new image or by providing differencing disks that give a difference between the original base and what you want to end up with now. Very important though, this is not infrastructure as a service. This is still platform. And we have a little slide that perhaps illustrates that. I can boot it, I can customize it, I can save my differencing, but essentially this storage, this blob storage, is where my virtual machine is actually stored and managed. Okay. So, a few questions around there. Will any Windows Server 2008 R2 based application work? No. Not necessarily. Yeah, it's important to recognize that there isn't any durability of the image. Yeah, if the virtual machine fails or the virtual machine is recycled, we've already said it's important to recognize that you'll lose some functionality. Does Windows Azure take care of everything? No, it doesn't. You create, you maintain the operating system. Azure does not understand how healthy the apps are that are running on your virtual machine. You are responsible for managing that. What does it cost? It costs the same as web and worker roles. So if you say, I want to have a small virtual machine role, it costs you 12 cents per CPU hour. 12 cents per hour, dollar cents. I can't believe actually I've been talking for 55 minutes. I should stop there and ask if there are any questions. Yes, sir.
About recycling, how often does that happen on the background?
Okay, how often does the recycling happen in the background? Very good question. There isn't really a definitive answer to that. If there were, it would be lovely. I can tell you that the guidelines are that a role will definitely recycle at least once every 40 days. Okay, so it might be that your role recycles half an hour after you deploy it. Yeah? Or it might be that your role recycles 40 days after you deploy it. You don't know when that's going to be. All you can do is write into your on-stop code the ability to clean up and tidy up after the work that you've been doing. So I'd love to be able to say it's every week, but it's whenever it is. Go on, Mika.
You said that if you exit the run method in a worker role, your worker role will die.
Yes.
Is that an event that is detected by Windows Azure, and which then would cause it to be spinned up again?
Absolutely. So on stop will still get called. Yeah. So if your worker role does die, then of course what we have in the background with web roles, worker roles, as one dies, another one will spin up automatically thanks to the Azure Fabric. And one of the things that I didn't mention, and perhaps should have mentioned, was when you say I want one instance, you don't get one instance, you get 3. Yeah, so you only pay for one, don't worry, you only pay for one. Yeah, but you will actually have 3 instances running, so that if one of your instances does die, yeah, then Azure can spin up another one for you and also fail over to one of the additionals. Yeah, so your role is not non-functioning, shall we say. Yeah. Yes, sir?
That swap feature is very nice.
The VIP swap, yeah.
Yeah, but sometimes just swapping is not that simple because you might have database changes, scripts, and the application might not be in sync with it. So how does that then fit in?
Absolutely. It's a good question. So sometimes if I just swap from staging to production, I may not have connection strings, for example, with my databases that are consistent. Yeah, I need to fix those issues before I do the VIP swap. Yeah, so I may well have something running in staging that says I'm talking to this database, I'm talking to this local resource. Before I swap, yeah, I need to make sure that I reconfigure those settings into how I want them to be for my production environment.
Database upgrade scripts and that?
Again, that's going to be your responsibility to actually manage those upgrades. Yeah, so that there's nothing built in that says, as I move from staging to production, that I can do all of these things for you. It is possible to have startup tasks that you could use to do those things, but again, you're going to be responsible for writing those.
Is there any downtime experience with the swap?
It's a very good question, that. So downtime with the swap, I've seen downtime be as little as like a second, yeah, to be as much as maybe 10 seconds. Yeah, so there is I believe there's part of the SLA that says what that downtime will be, but I've actually seen it between almost instantaneous up to about 10 to 15 seconds. Yeah. Questions, guys? Yes, sir.
Can you do a swap with virtual machine role, or how does it?
Can I do a swap with a virtual machine role? Yes, I can do that. Yeah, because I could have a staging virtual machine role, and I could have a production virtual machine role, and I could swap them over. Yeah, absolutely. Yeah.
Yeah, about the instance limits, you talked about 20 instances per subscription.
Uh-huh.
What's the process of having more? Because I just thought that if I have a credit card, I can say that, okay, now I'm running 2 instances, and okay, now I'm hitting a huge load, and I want to boost it up to 1,000.
I've actually written the next Facebook, yeah, and I want to have more instances than perhaps I'm allowed. That's one of those instances where you need to be talking to Microsoft. You need to talk to them locally, but I know that is perfectly possible to do. It's just as you have a subscription, the default is to say you can only have 20, because that should be enough for just about anybody. Yeah, but actually you may have applications that you do want to scale out past that. You know, you've been very successful with your business. Yeah, that's a conversation with Microsoft, but that's easily done.
Sorry,
No, that's okay.
On that web role, if I take, say, extra large instance, I get 15 gigabytes of memory.
You do.
Will IIS consume all 50 gigabytes? Because on a Windows server, you only have access to 30% of the memory.
No, it won't do. No, it won't do. I mean, that is available memory, but IIS won't necessarily utilize all of that. Yeah, there'll be the same limitations to on-premise. But you still do have that memory that you can use for processing, yeah, within perhaps a worker role, for example. Yes, sir?
Is there a way to add custom rules to load balancer?
Not to the load balancer, but you can now do clever things like auto-scale. So if you start to build yourself some performance counters, you can actually say, if the performance of my application falls below this particular threshold, then what I want you to do, Mr. Platform, is I want you to scale me out another instance. But in terms of special rules to the load balancer, not per se, although you can do clever things with something called Traffic Manager, which allows you to say, if I have services dotted around the world, if the service in, let's say, Asia becomes unavailable, then I want you to fail over to the service that's running in the States or Europe.
I was thinking more about the redirect rule. Let's say a customer, a client, try to access restore receipts on the application.
Mm-hmm.
I was thinking to add a custom rule at the load balancer that the request doesn't hit the application. Instead, it's redirected straight away from the load balancer.
No, I can't do that. No, I'm sorry. I should stop there, guys, because we're 1 minute over time. I hope I see some of you I hope I see all of you for the second session, and I hope you found it useful this morning.